Let's implement the algorithm we just designed to calculate the difference between the target value and the slider value in Kotlin. As you progress, you'll learn about conditional statements and how to use them in Kotlin. The first you'll be introduced to is the if-else statement. Let's get started. Before you write the actual Kotlin code in the function, let's write down the steps you're going to take to implement the algorithm. So here we say if something is true, we execute the code inside the curly braces. This is our first condition, and do note that this is a pseudocode and not actual Kotlin code. Pseudocode just helps us write out the steps to solve a programming task in a human-friendly way using plain human language. I'm just using this for demonstration purposes. You can also add an else-if condition like so. You can also have multiple else-if blocks. Then you can finally have an else statement at the end. This else statements block will be executed if none of the if and else-if blocks conditions are met. So the analysis of our pseudocode would be, if a condition is true, we execute that code block. Then else if we have another condition, then do that instead. Then finally, else if none of those conditions above are true, then we do something else. And do note that the hanging else block is optional. Sometimes, you might not want to do anything when the if and the else if blocks returns false. Cool. So now we are going to write a real Kotlin if-else statement. Convert the lines which contains the pseudocode into a comment by selecting them and pressing Command and /. You can see that double // are added to those lines and they turn gray. After that, declare a maximum score variable. This will hold the maximum score the player can get for a round. Next, you need a different variable to track the difference between the target value and the value of the slider. As you can see, we need to explicitly declare the type of the variable, in this case int, and this is because we have not initialized it with a value. So, Kotlin's type inference engine cannot determine what type of data this variable would store. But for max score, there was no need to add an int as a type because we initialized it with a value of 100. So, the type inference engine implicitly gives max score an int data type. If the value of max score had a decimal like 100.0, then the type inference engine would infer it to be a double data type. You get the idea, right? Okay, next, you set the value of the difference inside an if-else statement. Go ahead and enter the following code. The condition goes like this. If the slider value is higher than the target value, you subtract the target value from the slider value to get the difference. Else, if the target value is greater than the slider value, then this time around, you subtract the slider value from the target value to get the difference. But when these conditions in the if and else if blocks are both false, then it means that the target value and the slider value are equal. So the difference between both of them would be 0, and that's the situation we manage in the final else block. We assign a value of 0 to the difference. You can see that Android Studio complains that the difference variable is never used. Let's subtract the difference from the maximum score to get the points. Enter the following code. You can see, this is the value that will be returned from this function. And this value is the point for the round, and it is an integer value. Run your app. select the value close to the target value but below it, then tap the Hit Me button. You can see the correct points are displayed in the Alert dialog. Restart the activity once again to get a different target value. Then this time around, select the value a bit higher than the target value. Then tap Hit Me once again. Cool! The correct point is displayed and we don't have a negative number as the score. One last thing. Sometimes, Android Studio gives you some suggestions to optimize your code. If you look closely at the if keyword, you can see it is underlined, which shows a warning. Our code is not broken, meaning it will work, but Android Studio feels we could refactor our code with a better structure. Now, click on the if statement. Then click on the bulb icon. You can see it gives us two suggestions. It says we could use another type of conditional statement called the when statement. It also says that we can leave the assignment of the difference variable out of the if block. This is a good suggestion because, as you can see, we are assigning the difference variable multiple times. But if we move the assignment out of the if block, then the assignment will be done only once. Go ahead and select Lift Assignment out of if. Now the value of the difference variable is the result of the if statement. With this, you've reduced code repetition because the difference is assigned only once. You can still go further with refactoring if you want to. Now look at how the difference variable declaration is underlined with a warning. If you hover over it, the warning says that the declaration can be joined with the assignment. Click on the suggestion on the warning that says Join declaration and assignment. We can then remove the int type declaration we added, since the type inference engine can figure out the variable type based on the result of the if statement. There's another suggestion, but I'll stop here. The point I'm trying to make is that there are multiple ways of doing the same thing, and Kotlin gives you different constructs to suit your needs. I'll stick to the initial code we wrote because this is a beginner course and it is more readable to help you grasp the concepts. Syntax can always be Googled or looked up in the documentation. You'll learn many ways to refactor your syntax in Kotlin along this learning path. So I'll undo the changes by hitting Command Z until I get to the original code. But not to worry, you keep refactoring this code in the next episode to even have less code than this.